Hello and welcome to York Universe, the astronomy and astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I'm Paul Mackin, one of your hosts this evening, and I'm joined by my friend Maheen Mani, and we are affiliated with the Department of Physics and Astronomy here at York University. Tonight, we are broadcasting live from the Allan Carswell Observatory on the Keele campus in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal Time at York U Observatory. We also run in concert with our online public viewing, or as we call it, the OPV feed. Run. We also run in concert with our online public viewing, or as we call it, the OPV feed, run by the observatory staff, where, with it being winter and all, we are not observing due to inclement weather. The crew will be showing beautiful archival images and answering questions on YouTube chat tonight. To navigate to our live show and find out about us, please check out our website at yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. Any questions or comments you may have had on past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can also always connect with us on Instagram with the handle at York U Observatory, on Facebook or on Facebook at Allan I. Carswell Ob. All of our programs are free, but if you feel you'd like to make a donation, and we would certainly appreciate that, please see our website at yorku.ca/science/observatory. We will be monitoring the YouTube chat for questions and post content. We had a small technical difficulty. If you are listening to this podcast after the OPV, you'll notice a gap. We apologize for that. Basically, we just introduced everyone, and I will go over that information again at the end of our podcast. So, Maheen, how are you?
I'm very cold.
Oh, what a great lead into the weather. Yes, the weather is terrible. It's just horrid. I think we're now at the longest cold streak in southern Ontario since like the 1970s.
Hmm.
Um, I had my telescope, one of my little telescopes, out last night. The temperature was minus 30 Celsius. I have no idea what that is in Fahrenheit, but it's probably irrelevant. It's so cold. But it was very, very cold. And my little telescope, it's an automated telescope. And so it was programmed to take images all night. And when I got up this morning, it had been observing from 7 p.m. till 5 a.m. So, 10 hours. I got up and there was one little battery light left on it as it was sitting outside. And I had it plugged into an external battery pack as well. It just barely made it through the night, but I got a lot of great data gathered. So it was a rare clear night. We don't have one tonight, but I take it where you are, Maheen, it's also not clear. Is that correct?
Yes, it's starting to get very cloudy. Snow is expected to come in tomorrow, and dare I say, I mean, as beautiful as snow is, my eyes are just craving to be able to look at some greenery and then also be able to look at some clear skies without freezing. Um,
Yeah,
yeah.
it's just horrid. Again, everyone looks at snow and it's on the trees and it's pretty and just but 30 days in, you really do want it to, go away. So, but the good news is February's the shortest month of the year, and we are now more than a quarter of the way through it. So, um, in terms of the night sky, when it comes back, though, there's a lot going on. Uh, Jupiter was in opposition last month, so it's very high in the night sky. If you go out at night and you look up at the night sky, you are going to see Jupiter. It is this whomping big, bright, looks like a star. I mean, there's a way to tell it's not a star, and I'll get to that in a second. But it's really bright, and it'll be almost, kind of directly overhead a couple of hours after sunset. You can tell it's not a star because if you look at it closely, stars twinkle and planets don't. And there's some technical reasons for that, but that we don't need to get into here. But Jupiter is very, very bright. It's far brighter than almost anything in the night sky around it, except maybe the moon. The moon is definitely brighter. Um, Jupiter's not the brightest of the planets. We'll talk about another one in a second, but it is the second brightest of all the planets, and you can really see it, how bright it is. The moon, right now, we're into the last half of the month for the moon. So the moon doesn't rise. It'll be a crescent, doesn't rise till late at night, early in the morning. Saturn, on the other hand, is visible after sunset as it's kind of a dullish, brightish yellow star in the western horizon at night. Venus also is a very bright star. It is the brightest object in the sky, other than the sun and the moon. Quite a bit brighter than Jupiter. And it's visible just after sunset right now, but it will rise in the evening sky as we get further and further into later winter and early spring. Also, this is a great time to look at the constellation of Orion, uh, which is the absolute star of winter constellations. Maheen, do you have a favorite winter constellation to look at?
I think Orion has to be my favorite too because I love the Orion Nebula. Like the colors,
Yeah,
everything is just so beautiful.
it is, and Betelgeuse, which is one of the stars in the shoulder, is very bright and quite red. And then under the belt, you've got that sort of fuzzy area, which is where the nebula is. My telescope last night was actually shooting one of the other nebulas, which was the Horsehead Nebula in Orion. It's just lovely. But we've also got spring constellations starting to appear if you stay up late. And I always take that as a sign that spring is on its way. So last night I was taking some pictures of the Leo trio, which is these three galaxies in the constellation of Leo. And Leo is very much a late winter or early spring constellation. So it's rising and spring is coming. And we should all take that as, even after this horribly long period of cold, that spring is on its way. Um, so I think it's time to move into this week in history. And Maheen, you've got a story about humanity's first asteroid landing. So why don't you take it on? There you go.
Sure. So, starting off with this week in space and astronomy history, on February 12th, 2001, NASA spacecraft NEAR, which stands for Near Earth Asteroid Rendezvous, landed on an asteroid called 433 Eros. What makes this landing special is that it was our first ever landing on any asteroid and the first time a human-made object ever orbited an asteroid. So NEAR's timeline since launch in February 1996 included a flyby of the asteroid Matilde. It also included a flyby of Earth for a gravity assist, and then a flyby of Eros, after which it entered the orbit of Eros, and an unexpectedly successful touchdown of Eros in February 2001, which I will be talking more about later. So, the interesting thing about this mission and the Near spacecraft is that it was not initially designed as a lander. So, the goal was only to orbit Eros for data collection. However, it ended up surviving a touchdown on the asteroid and returned further valuable data for almost 2 weeks. So Eros was the first near-Earth asteroid. It was discovered in the year 1898, and Near first flew by it in December of 1998, since its launch in 1996. And this was at a distance of about 3,800 kilometers. And after several trajectory adjustments while it was in the orbit, um, it finally moved into the orbit around the asteroid, and this was on February 14th, 2000. In the first flyby, it was found that Eros was smaller than expected and it had two medium-sized craters. It had a long surface ridge and a density similar to Earth's crust. So, not the entire Earth, but just the Earth's crust. The spacecraft was meant to gather data on the asteroid's physical properties, mineral components, morphology, internal mass distribution, and magnetic fields. It relied on solar cells for power beyond Mars's orbit for operations. And it was also the first spacecraft which did that, meaning that the first spacecraft which ever relied on just solar cells for power. Many of the mission's goals were successful, as it showed that. So, some of the things that it found was that Eros had no magnetic fields. It was also able to map more than 70% of the surface using the near infrared spectrometer and provided useful data about the asteroid's interior. It returned about 10 times more data than originally planned, and that can be attributed to the fact that it ended up landing, even though it was originally planned just to orbit the asteroid and not land on it. And this 10 times more data included 160,000 images, which is a lot of data to process, but you cannot complain about it. The more the data, the better it is. So it was a mission that would be considered more than successful since it went unexpectedly above and beyond in providing us with information about arrows. As I said, it gathered 10 times more data than we originally planned, as well as this was also a great way of having received an understanding of how we should go about instrument design for rovers, such that if they were to land, they could select samples from the surface, look for the presence of water, or conduct surface mapping for future mining, and which is a useful study for future space missions.
Yeah, it's an interesting story. There's a couple of things that are not well known about this mission. Number one, the spacecraft en route got renamed.
Hmm.
So it wasn't actually it was launched as the Near spacecraft, and then en route it got renamed as Near Shoemaker, named after Eugene Shoemaker, who was actually kind of responsible for the astronauts' geology training on the Apollo missions, but was also big in general space science, particularly asteroids. Quite an interesting fellow in his own right. And and Maheen, you also mentioned the first flyby of Eros. So here's the story. There was no planned flyby of Eros. It was going to fly by Matilda, get to Eros, and go into orbit.
Hmm.
Just before it went into orbit, it started spinning out of control and went into safe mode. So they couldn't do the burn to put it in orbit. It then flew by. They managed to get some images and they had a flyby. And then orbital mechanics, 2 years later, it went into orbit. And then the mission unfolded exactly as you described. But yeah, it was a miss, and they basically pulled success from that failure,
Hmm.
and it's really remarkable, actually. And I actually remember I was for some reason I think I was the night it failed to go into orbit. I think I was in an airport somewhere and following it sort of on the nascent internet of the day and shaking my head. But NASA was able to NASA and JPL were able to pull this victory from the jaws of defeat.
Yeah.
It's really an amazing spacecraft. and the landing was totally a bonus.
Yeah, it's interesting how like sometimes the missions are so perfectly planned, so well executed, and they still don't go as you want them to go. And then there's missions like Near, which was, it was planned well, but it didn't execute well, and yet it was still a success. So, yeah, you never know how these missions will end up.
Yeah, so it's really interesting. There's another mission that I'd like to talk about that also was a very successful mission, but also started off with almost a catastrophic failure. Um, so a little going back a little further, February 8th of 1974, the American astronauts left Skylab, their first space station, excuse me, for the very first time, by the very final time. Skylab was the United States' first space station. It was launched by NASA and occupied for a total of about 24 weeks between May 1973 and February 1974. That was the Skylab 3 mission. Uh, so uh, it was operated by three different astronaut crews: Skylab 2, Skylab 3, and Skylab 4. And what it was, rather than build a space station from scratch, they took an Apollo Saturn V rocket, which was an incredibly powerful heavy lift vehicle. And they hollowed out basically the third stage, and they built a space station in it. And they put on solar panels, and they attached a really great solar telescope on it, and they put a docking port on it that would allow two Apollo spacecraft to dock to it. And they then put it back on the Saturn V, the upper two stages, and that was the launch vehicle. Uh, so it was launched by a modified Saturn V rocket, uh, and and that was the last Saturn V that was ever launched. So the launch is sometimes referred to as Skylab 1, but what happened was shortly after takeoff, basically a panel flew off, and it severely damaged the space station during launch. And when it got into space, it lost the station's micrometeor shield, which also served as a sunshade, and lost one of its solar panels. Um, the debris from the micrometeor shield became tangled in the remaining solar panel, which meant it couldn't open. So they had this very wounded space station in orbit. It really wasn't generating very much power, a little bit, but it was getting directly heated by the sun, and it was getting ridiculously hot. So the next mission was supposed to go up a couple of days and commission the space station in orbit. That was Skylab 2, and it was commanded by a guy named Pete Conrad, who was he was the third man to walk on the moon, and he was probably one of the most intense, driven astronauts they had in the astronaut corps at the time. Uh, Very famous for his potty mouth, and that became a part of the story later. And so he and the crew quickly were retrained, and some devices were designed to help them save the space station. So a little while later, they took off. Uh, in This was like 10, it was supposed to be like 2 days later. They did it in 11 days, May 25th, 1973. And it was a Saturn 1B rocket. And they got there, and their job was to, first of all, put a parasol uh, on top of the space station to get the temperature down, and then to go out in a spacewalk and unjam the remaining solar panel. And this is where Conrad's potty mouth became kind of famous, because he was breathing heavily and cursing under his breath. And of course, all this was caught by a microphone, and a lot of it got broadcast live. But they got the parasol like sunshade through a small instrument port in the side of the station, and they brought the temperature down and prevented overheating that would have melted the insulation. And that melted insulation would have released poisonous gases in the station. Uh, uh, that solution was designed by a guy named Jack won Kinsler rather, who won NASA's Distinguished Service Medal for his efforts. The crew conducted two spacewalks for repairs. They stayed in orbit with Skylab for 28 days and basically got the system running. So then they had a second mission, Skylab 3, which launched on July 28, 1973. Um, and I think they were up there for about 60 days. And that mission, interestingly, was commanded by Allan Bean, who was the fourth man to walk on the moon. He flew on Apollo 12 with the aforementioned Pete Conrad. And Allan Bean's really interesting because he had a very colorful career after NASA, and we'll talk maybe a bit about that in a second. Um, but and then after that, on November 16th, 1973, Skylab 4 flew, and that mission lasted 84 days. So the last Skylab crew returned on February 8th, 1974. Now, prior to departure, about 80 instruments were named, although they were described as almost 300 separate investigations. The experiments were divided into 6 broad categories: life science, which is human physiology, biomedical research, circadian rhythms for mice and gnats, solar physics and astronomy. So they had a great solar telescope, but they had other telescopes as well. And they actually managed to, this was the thing around then, there was a comet, supposedly the comet of the century, Comet Kahutek, totally fizzled. Although I did see it. But there was some observing of that. There was some stellar observations in space physics. They did mineral resources and geology, hurricanes, land and vegetation patterns, material science, welding, brazing, metal melting. They did 19 different student proposals. Uh, and several were commended by the crew, including dexterity experiments and test of web spinning by spiders in microgravity. Uh, there was human adaptability studies. And because the solar scientific airlock, one of the two airlocks, was unexpectedly occupied by the parasol that replaced the missing meteorite shield, a few instruments instead were installed outside with the telescopes during spacewalks, or moved around to the Earth-facing airlock. So Skylab 2 had less time on the planned experiments due to repairs. On the other hand, Skylab 3 and 4 far exceeded the initial experimental plans once the crew had adjusted to living in the space station. And I will say, obviously, I was never in Skylab, but there was a Skylab 2 planned, and it is at the Smithsonian National Air and Space Museum in Washington, and you can walk through it, and it's huge. This is not a cramped little space station. It's big. It's the entire upper stage of the Apollo. So if ever anyone's down in Washington and they get a chance to see it, it is absolutely worth going to that museum and seeing it. So the Skylab 4 mission had an entirely rookie crew: Gerald Carr, Edward Gibson, and William Pogue. And that was the only mission they ever flew. But they were in space for 85 days, launching November 16th, 1973, and returning on February 8th, 1974. So they had New Year's in space, which is kind of cool. And I will tell one other Skylab story, a small one. So Allan Bean, I mentioned him earlier, walked on the moon with Pete Conrad. After Skylab, he worked on instrumentation design for the space shuttle, and then he retired from NASA. And his post-NASA career was really fascinating. He became an artist, and Like all great artists, he painted what he knew, and he styled his painting style is very similar to Monet in some way, with the use of colors, and it's impressionistic. But he painted the astronauts on the moon. And I'm very happy to say that I have a couple of his limited edition prints in my house. And uh, he passed away a few years ago, and Pete Conrad years before him in a motorcycle accident. But, he left a legacy of his work with that.
Yeah, it's very also very interesting to hear about like the first ever space station of the US. And on the topic of the damage of space station, I just want to mention that there's this thing called a natural decay of space stations, which is where they, gradually passively decrease in altitude due to atmospheric drag, eventually, which, leads to its re-entry into Earth's atmosphere. And so they have to be very quick about dealing with any defects because they don't want, a satellite just this is true for satellites, but it would be even more dangerous for like something as big as a space station for it to, re-enter Earth, because this can happen because there's atmospheric drag, where space stations collide with air molecules, and the friction causes the station to lose kinetic energy, and its orbital altitude reduces. So there's this thing called a feedback loop where the more drag causes a faster decay. And so there's required maintenance where they need to reboost the station and push it higher to ensure that it remains in the required altitude. And so, your mention of people flying over to fix all the defects, yeah, that's very important for them to do. So that was very interesting.
Yeah, and it's interesting that you mentioned that, Maheen, because that's eventually what happened to Skylab. What originally, when they did the final Skylab mission, there was going to be a second phase. First of all, there was going to be a Skylab 2. The funding for that got canceled. And that's why I got to walk through it in Washington. Um, but then they were going to have a space series of space shuttle missions to Skylab with the hope of boosting it in its orbit. But the space shuttle got delayed, and eventually Skylab re-entered Earth's atmosphere, and they set it up so that it came down over the Pacific Ocean, as did the Mir, the Soviet Mir station many years later. Um, but it was exactly experiencing that phenomena. And of course, with the solar panel and the parasol, there is what limited atmosphere there is drag.
Hmm.
So yeah, it burned up over the Pacific Ocean. Several pieces did come down in Australia, as I understand it, but for the most part, it was successfully cremated after a great successful mission. And of course, now we've got the International Space Station, and it's been operating for a very long time. And we'll be talking more about the International Space Station and its successors in upcoming podcasts. But I see that we're coming up on the halfway point. So just a couple of reminders. First of all, you're listening to York Universe, the Space and Astronomy podcast from York University. We are broadcasting live from the Allan I. Carswell Observatory at York's Keele campus in Toronto, Ontario, Canada. Please take a look at our website, yorku.ca/science/observatory, to join the chat for our online public viewing, which is going on right now with some great archival images, including one of my favorite M8, and we also got M66 up there, and Betelgeuse, which I mentioned earlier, a star in the constellation of Orion. Um, Tonight, you are listening to Paul Mackin and Maheen Hamani. Also, regular observatory tours. I believe our tours are continuing this week. You need to go to the website for York University. Again, yorku.ca/science observatory. There you can get an online free ticket, but we do ask you to get the ticket in advance. Um, and just a little plug here. If you're online, you can also purchase our 2026 Observatory calendar. It's only February. There's lots of months, and there's 14 great images in the calendar. So fantastic images for your wall or your fridge. I've got one on the wall, and my wife's got one downstairs on the fridge. Um, Captured by these images are captured by the students and friends in Observatory, and this calendar only costs $15, and all the funds go to the observatory, where we're totally volunteer run, and these funds go a long way to help us maintain some great work. So, with that being said, Maheen, you've got a story in the news. Let's talk about your first story.
I have. I'm kind of excited for this one, but let's get into it. So, although not exactly news from this week, it is very much in line with the work I am currently doing as a researcher at York. So, I will be sharing some rather recent news about dark matter. Essentially, at York, as part of Dr. Sean Tulin's group, I work on simulating an alternative form of dark matter called self-interacting dark matter. And recently, there was a paper published by two physicists at Perimeter Institute, James Gurian, I hope I didn't butcher the last name, and Simon May, in which they discovered a new way of simulating this form of dark matter. So, the major benefit of their work is that they explore certain types of particle interactions that were previously difficult to model accurately. But before I jump into the technicalities, a quick overview of dark matter for the listeners. Research suggests that 85% of the matter of the universe is still unknown. All we know for certain is that this type of matter is different from visible matter, which includes things like stars, gases, and other things that we can see. Dark matter we cannot see, and we only know about it from its gravitational effects on visible matter. Although many believe that this matter is cold and collisionless, and by many I mean cosmologists, alternative theory suggests that it could be self interacting, meaning that dark matter particles interact with one another, both elastically, meaning while conserving energy, and inelastically, while losing energy if dissipation is included. So, a lot of the people are working only on self-interacting dark matter, which is that they only consider elastic collisions. However, some are also including these inelastic collisions and calling it dissipative self-interacting dark matter. So, such interactions can influence the massive concentrations of dark matter around galaxies and help guide their evolution. The way physicists often explore such theories is by simulating the particles and their interactions, assuming different theoretical models, and then studying the evolution of dark matter halos on their own. So, one such approach would be something called an N-body simulation, which is efficient when dealing with dark matter. Um, such that it is not dense and collisions are infrequent. The other is a fluid approach where we consider particles as fluid. So if we were to take two different particles, which something we learn about in physics classes where there's a particle, it gets excited. So we have two different types of particles, a ground state particle and an excited state particle. We consider both of these types as a fluid. So the excited state particles is one fluid, and then the ground state particles is one fluid, and then they interact with one another. There's also some work where these two fluids are considered equalized, and we consider it as one fluid, which is something I'm working on as well currently. But this is one of the approaches. But this works well when we consider dark matter, which is not dense. So it's sparse, there's less collisions, and it works for that case. However, in real life, there can be cases where dark matter is neither dense nor sparse. And this is where these physicists came in and they dealt with the intermediate range of densities. So essentially, they developed a new code which has this name called KISS SIDM. So it's KISS SIDM, where they bridge the gap between existing simulations, which deal with more dense and less dense dark matter types, um, And this code deals with this intermediate case. And the way it does it is that it is a code which requires less computational power, which is something that can be an issue when we deal with n-body simulations. We need to usually run these on clusters, which are expensive, and you can't necessarily run it on your computer when dealing with a large amount of particles. However, this code can be run on your laptop, and it is computationally inexpensive. And the benefit of this work is now that it will allow researchers to conduct further studies on different models and consider all possible dark matter densities while studying the evolution of halos and uncovering the truth about dark matter. But yeah, so it's quite an interesting thing, especially for me to hear about because this is something that I've been working on and we haven't been able to consider this intermediate case. So when I learned about that, I was really excited.
Yeah, it's interesting. I mean, I'm not a specialist in cosmology. My primary interest in astronomy is planetary astronomy, but I remember when I took one of our courses, a second year course in astronomy, we talked about dark matter and I've often thought that dark matter is one of the most misleading named things, and part of that reason is it, there's there's definitely a gravitational effect that we can't explain,
Hmm.
uh, and gravitational effects are are generally tied to forms of matter. But we don't know. Is it something, as you said so well here? I mean, is it something mysterious, or is it just matter we can't see? Is it baryonic matter that we can't see, or is it something else? And if it's something else, what are the rules, right? It's matter. It definitely exhibits gravitational effects. So does it behave like baryonic matter? Do they bounce off each other? Does it interact with each other? And we really don't know. And it's interesting to note that I didn't know Professor Tulin was working on this. He's actually one of my professors this term for a computing course. And I see that this is a highly computing intensive program. How did you end up working on it?
So I started working on this, I think one of the summers. I got a rate position and I was basically studying the collapse of dark matter halos to form black holes. So you know how we studied that there were supermassive black holes early in the universe and we don't know how did they come into being, which is also being confirmed by a lot of data from James Webb recently. And one of the theories is that if we were to consider that dark matter is self-interacting, then it could potentially dissipate and collapse in on itself. So there were dark matter halos early in the universe that collapse in on themselves and potentially form like a seed for a supermassive black hole. So that was something I started working on. And then eventually, as I graduated, I kind of got a position with him where now I'm working more on other kinds of stuff. So we're looking more particles and halo evolution and galaxy evolution as well. Yeah.
Fascinating. One of the things that I've so enjoyed about coming to school, back to school, is kind of the quintessential mature student, because I am really mature. But one of the things I'm fascinated is how much the students get involved in the professor's research, and it's very gratifying because York does some excellent research, and the physics department at York is really engaged in research and heavily leverages a
Hmm.
talented pool of students, and that's so gratifying to see.
I totally agree. One thing I do want to say, York is a great place for research. Also, another thing I want to say is that you mentioned that dark matter, we think that dark matter may be baryonic, but that's not true. I think that we have come to a point where we're sure that it is not baryonic matter, but we don't know what it is. So that's like one thing that it's not baryonic. Like we know that for sure.
Interesting. I mean, it's probably outside of the scope of this conversation, but I did not know that.
Yeah.
But again, not a particular area of my study. but I was unaware of that. So that's interesting. Well, perhaps on another show we can talk about if it isn't baryonic,
I'd love
what
that.
is
Yeah.
it? Yeah. Um, so I will talk about another kind of matter problem with regular baryonic matter, the hydrogen atom. So other than being the hydrogen atom is interesting. Other than being a way we torture students in quantum mechanics with models for it, uh, it is also very, very small. The hydrogen molecule is two hydrogen atoms, is very, very small and agile. It moves around easily. It can wheel its way through just about anything. And this has been a big problem for NASA in the past and now. Uh, Older spacecraft and older rockets and rockets like SpaceX's Falcon 9 use a combination of kerosene, supercooled kerosene, and liquid oxygen, and they use that as rocket fuel for the Falcon 9. The Falcon Heavy is using methane and oxygen. Um, but other rockets, space shuttle, the upper two stages of the Saturn V used liquid hydrogen and liquid oxygen, which gives a very high specific impulse. It really moves things forward. Um, so when it was announced that Artemis might fly in February, people were excited, obviously, but there was sort of a lot of people in space science looking at each other, going, "Yeah, that'll be the day," because just before launch, you do sort of a dress rehearsal where you load the tanks and with fuel and whatnot, and invariably, when you're dealing with hydrogen, you are going to find leaks. So Artemis has had to they have to stand it down, and it's not like they can just drain the tanks, fix the leaks, refill the tanks, and launch. They can't because Artemis needs to get to the moon when the moon is in a specific position with respect to when Artemis launches. It's got an observing plan at the moon, so the moon has to be lit the right way by the sun, so it has to be in a particular position with respect to the Earth. And what that means is they can only get a launch window about once a month. So what will happen is later this month, they will again, or early in March, they will again do a dress rehearsal. And assuming they fix the leaks, and they may be some other problems they've got to deal with, assuming they've done all that, then they will be able to launch. But you can't launch a rocket that could explode on launch because it's leaking fuel. So, safety first, people, right? You have to be very careful. And I know people get cynical about this and say, oh, they're always delaying it. They're delaying it for very good reasons because we don't want to kill astronauts. We don't want rockets blowing up. And these are complicated uh, machines and dangerous machines if things go south. So, don't be surprised if we get another stand down. It's going to be very exciting when it's launching. I'm thrilled to see us going back to the moon because I remember the time we went to the moon before. I remember watching the first lunar landing, and I remember thinking when I was like 12 years old, I would have been 12, maybe 13, uh, when Apollo 17 came back to Earth, and that was the last lunar mission in the 20th century. Well, here we are now, a quarter way through the 21st century, and we still haven't gone back. So I'm really excited about this. In fact, yesterday, one of my 3D printers wasn't doing very much, so I printed the Orion spacecraft. So no one's more excited about this than me. But to our listeners, I would say deep breath. They'll launch it when they launch it because we want this mission to go right.
Yeah, it's definitely really sad when they cancel these things, but sometimes I guess you just forget the scale at which they're working and how much they want it to be a success because of the amount of money that goes into it, the amount of work that goes into it, and the fact that this time there are people that are going and it's not just machinery, like it's actual people. So they have to be
Yeah,
careful.
they do. But we're getting through our time, Maheen. So maybe you want to tell us about Comet C 2026 A1.
For sure. So I want to encourage the viewers to keep an eye out for the newly discovered comet in April. A new comet called C 2026 A1, also known as MAPS, was spotted by four amateur astronomers on January 13th of this year. They observed it with a remotely operated telescopes in the Atacama Desert. This comet is a member of a group called the Creutz sun-grazing comets, which includes many of the brightest and most spectacular comets ever seen. It is moving on an extreme and highly elongated orbit around the sun, and is expected to pass within just 120,000 kilometers of sun surface in early April. Generally speaking, sometimes comets can break or fall apart due to thermal stress and gravitational forces when they approach the sun. And so, if it remains intact, it may become visible even in broad daylight while being closest to the sun. So, it is bright enough that it might be visible even in broad daylight if it survives. Usually, comets are discovered when they are closer to the sun than this specific comet, meaning that it is the first new grazer discovered, which is much farther away from the sun at the time of its discovery in comparison to those previously discovered. This has made astronomers believe that this comet is either a reasonably large fragment or it is currently falling apart. However, with its recent observations, which show that this comet is brightening steadily, it suggests that it might just not be falling apart and it is actually that bright. And if it does survive, it can put on a great show in early to mid-April, which is exciting. However, it is still too soon to confirm with certainty that we are going to be able to see it as it could fall apart. We don't know what's going to happen in the upcoming few weeks, potentially the entire month of March. So this is something to, watch out closely for. Prepare your telescopes, prepare your observing equipment, your equipment for photography, because this is something you don't want to miss if we get it. But if we don't, you have to just watch the news closely. It is a waiting game for now.
Yeah, there's comets are wonderful. I've seen a number of them, but the big problem is hype. People get
Hmm.
hyped. I mentioned when Skylab was there, Comet Kohoutek. That was the big comet, the comet of the century. And the problem is when comets get close to the sun, they often break up. Not
Hmm.
always, um, but one keeps hoping because when you actually see a comet, it's spectacular. And this one, that close to the sun, if it survives, it's going to be a beauty. It really is. It's just, yeah, fingers crossed, toes crossed, whatever you can cross, let's cross it. And a spring comet. Wow, that would be just fantastic.
Have you ever seen a comet that was visible during the day?
Um, no, I've never seen I'm trying to think. Hale Bopp, no. Hayakatake, no. Kotak, definitely not. No, I have not. At
Yeah.
sunset for sure, or
Uh-huh.
sunrise for
Yeah.
sure. Many, including just 18 months ago when there were a couple of comets then. But no, I've never seen one that bright.
Yeah, it would be very interesting to be able to see it during the day. It sounds very unnatural, but if it's so bright, then it would be visible. So,
Yeah. One of the things that does happen during total solar eclipses is that if there are comets near the sun, those can become visible during an eclipse, as
Mhm.
can planets that are sort of in the general region of the sun. So in the eclipse we had not like almost 2 years ago now, uh, I was able to see Venus clearly, and I think Jupiter that day, but I didn't notice any comets. But it was in and out of cloud, and it was sort of a mixed viewing experience. But I could definitely see Venus.
Yeah, that would be very interesting to actually be able to look at even comets like during a solar
Yeah,
eclipse. Yeah, for sure.
yeah. So for our last item, I'm going to leave astronomy a little bit, and I'm going in a slightly different direction. We're going to talk about the Super Bowl. Not the Super Bowl specifically. I'm not much of a football fan, but uh, yesterday during the Super Bowl, of course, there's a famous halftime show, but there's also advertising that goes on in the Super Bowl, and there were two movie trailers that came out. One is the new Steven Spielberg film called Disclosure Day that I don't really know a lot about. It seems to be kind of a UFO story, a little creepy in the ad. But the other one I do want to talk about is Project Hail Mary. Now, many of our listeners might have read a book or seen the movie The Martian by Andy Weir. Project Hail Mary is, I think, his third or fourth book. Um, and it is in some ways similar. So here's the setup for Project Hail Mary. A guy wakes up. He seems to be in some sort of hospital bed. He doesn't know who he is or where he is. There's machines all around him that seem to be taking care of him. But he can't get out of the hospital bed, and he's exhausted, and he's clearly been unwell and falls back asleep. And a couple of days later, he wakes back up, and this time he's able to sort of get himself out of the hospital bed. And in the hospital bed, there's two other beds near him, and they both contain dead bodies. And this guy has no idea who he is or where he is or why he's there. That's the starting premise for Project Hail Mary. It's a science fiction story about, and if you see the trailer, and there's no spoilers here, the trailer's out there, but if you don't want to hear any spoilers at all for the movie, now's a good time to not listen. But the basic premise is that something goes wrong with Earth's sun, and humanity's on the verge of extinction, and a sort of a long shot attempt to fix it. They find several other stars nearby have similar problems, but one doesn't. And so they engineer a spacecraft that can get there, but it's going to take quite a few years. And they put three astronauts in suspended animation to go there and try and figure the story out and what's going on. And when they get there, couple of the astronauts are dead, but someone, as I said, only one star. It's not only one star that was affected; other stars are affected, and they also have inhabitants around that star who have the same problem. But the film looks fascinating. Some of the online, I've read the book, as I said, and if you saw The Martian, which was a great film, uh, this one looks to be, I would say, even better, spectacular, quite moving. There were people uh, commenting online about how the trailer made them cry, and it does have a strong, a lot of emotional context in it. It stars not Ryan Reynolds. Oh, I'm drawing wrong guy. I'll have to quickly look at who's it's starring, but. It stars a Canadian actor.
Is it
Hail
Ryan
Mary.
Gosling?
Sorry, it is.
Ryan
Uh,
Gosling?
yes, it's Ryan Gosling. Yes, I always get the two confused. Who also played Neil Armstrong in the movie First Man. But it stars him, and the other main character is a puppet. Um, but you'll really enjoy this film, I think, if you like space movies and you like space science. Weir is known for being a hard science fiction writer, meaning he tries to make things as scientifically accurate as possible, but he's also got a good sense of character. So I'm thinking this is going to be a very, very good film, and I, for one, am extremely excited about it. And I'm probably going to see if I can get a whole bunch of the people from the observatory to go see it with me on opening day, which is, I think, March 20th. And Maheen, if you're interested, you can come with us.
Yeah, sign me in.
Yeah. So, again, the movie follows this idea of a lone person trying to solve a series of very challenging scientific problems. The Martian did that very, very well. This movie, but that astronaut had NASA to help him. This astronaut is too far away from Earth for Earth to even know he's still alive. So he has to rely on someone else. So there's very good character development, very good relationship development, and I think it's going to be very exciting. The other film, Disclosure Day, as I said, UFO story. Don't know a lot about it. Looks intriguing, a little scary. Um, but those were the two big Super Bowl movie trailers that I noticed. I think there was one other for a superhero film, Supergirl or something. But I think it will shape up to be an exciting spring and summer for movies. And I like to go to the movies, but this year there's been this so far this winter there's not been very much to go to. So I've had to content myself with being an astronomer and reading a lot. Um, but we're coming a little bit close to the end now. So I want to talk about one other initiative that the observatory is working on, which is our pop-up astronomy uh, initiative. Um, this is a bit unusual to be talking about it because it's kind of going to be unannounced the day it happens. So the idea here is that when the sky is clear and when the right things are going on in the sky, like Jupiter in the right position and the moon being in the right position, a few of the people from the observatory are going to hit the streets with a telescope or two, and just stand there and let people look through them. And we're going to try and do this once or twice a month. We tried to do it in January, but the ridiculous cold snap we've been having and the ongoing cloud just didn't make it possible. And we're going to try and do it again, maybe late February. We will certainly be doing it March, April, May, and into the summer. So you may hear about it, you may not. You may just be near a subway station somewhere and see a bunch of people with some telescopes and people hopefully lining up to look through those telescopes. But this is, astronomy is participative, at least at least in a visual sense. You can look at the moon, you can look at Jupiter, and you can get a feeling. You'll get an amazing feeling by looking through a telescope and seeing these things. So we encourage you to come on the observatory tours, and if you happen to see us out on the street with a telescope, pop on over. We don't charge for any of this. We encourage you to participate and hope you will. So, with that, I'd like to move on to some closing remarks. It's time to close up our podcast for this evening. Thank you for joining us. You have been listening to York Universe, the astronomy and astrophysics uh, podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Maheen Hamani and me, Paul Mackin. Also, special thanks to our OPV crew and our podcast coordinator, Julie. This podcast and past episodes of this podcast are available wherever podcasts are distributed. You can always connect with us on Instagram at York U Observatory, on Facebook at Allan I Carswell Obs. Our website is yorku.ca/science/observatory, and we have a lot of interesting content. And if you feel so inclined, it's a great place to make a Canadian tax deductible donation to our student operated not for profit observatory. Thanks for tuning in this evening. Clear skies and good evening. And everyone, please try to stay warm. I'm told the weather should be getting better soon. Try to stay warm. Take care and have a good night.
Have a good night.